Good afternoon to all. Welcome back to chemistry class. Today we are going to study about stability of half-filled and completely filled orbitals. Okay, we are going to study about stability of half-filled and completely filled orbitals. Okay, as we know, half-filled or completely filled orbital are more stable than partially filled orbitals. Do you know about half-filled or completely filled or partially filled orbital? What do you mean by half-filled orbital? Half-filled orbital means, suppose I am taking the p orbital. How many orbitals are having in the p subshell? There are 3 orbitals. Suppose here 3 electrons are having here. The 3 electrons is equally distributed in the orbital. Okay, each orbital equally distributed the electrons in the p orbital. That is the half-filled orbital. Okay, suppose here 6 electrons having the p orbital. That is, these 6 electrons are equally distributed in the p orbitals in the p subshell. Okay, this is called a completely filled orbital. Okay, you know, each orbitals can capacity to exist 2 electrons. Okay, so in the case of completely filled means p orbital, it should have 6 electron. Okay, the p orbital, it has the maximum capacity for exist of electrons is 6 electron. Okay, maximum capacity 6 electron. So 6 electron means it is completely filled. Okay, what do you mean by partially filled? Partially filled electron means suppose here having 2 electrons or 4 electrons. This is the partially filled orbitals. Okay, this is the half-filled orbital, this is the completely filled orbital, this is the partially filled orbital. Okay, so the half-filled or completely filled orbital are more stable than partially filled orbital. Okay, why it is more stable than partially filled orbital? What is the reason? Okay, so what is the reason for the stability of half-filled or completely filled orbital is there are 2 reasons are there. Okay, what are 2 reasons? First one, symmetrical distribution of electrons. First reason, symmetrical distribution of electrons. Second reason, exchange energy. Why half-filled orbital or completely filled orbital more stable? Because the symmetrical distribution of electrons between these orbitals, and second one, exchange energy of the orbitals. Okay, what do you mean by symmetrical distribution? Symmetrical means, you know, symmetry means equal. Okay, symmetry means, you know, it is same or equal. Okay, so symmetrical distribution of electrons means equal distribution of electrons in each orbitals in the same subshell. Okay, equal distribution of electrons in each orbitals in the same subshell. For example, here we are taking the p orbital. Here, suppose here having 3 electrons in the p orbitals. It is the equal distributed electron. According to Hund's rule, we can write the equal distribution of electrons. Okay, first one, singly the electrons fill with singly after each orbital. After filling the singly, then we can pair up the electrons. Okay, so this is the half-filled orbital. So, okay, this is the symmetrical distribution. And in the case of completely filled orbital also, it is very more stable than half-filled orbital. Okay, why it is stable? All the 6 electrons are strongly attracted by the nucleus. Okay, so it is difficult to remove the electrons from this orbital, from this outermost orbital. So it is become very stable. Okay, so half-filled orbital or completely filled orbital is very stable. Okay, because of the symmetrical distribution. For example, I'm taking the p orbital. This is the p orbital. This is the completely filled p orbital. Okay, how it will be distributed? First, this is the nucleus. This is the px orbital. Here, how many electrons are having? 2 electrons. I'm taking the completely filled orbital. Here, 2 electrons are having, and this is the py orbital. Here also 2 electrons are having, and pz orbital also having 2 electrons. Okay, so for each orbitals are equally distributed the electrons. Okay, here also the shielding effect is very small. Shielding effect is very small. What do you mean by shielding effect? Shielding effect means suppose some orbitals, some electrons, it exists in between the nucleus and the outermost orbital, and it hides the attractive force between the nucleus and the electrons. Okay, it hides the attractive force. Okay, so the attractive force is very small between the nucleus and the electrons. So it can be easily remove the electrons from the outermost orbit because of the attractive force is very small. That is called a shielding effect, otherwise called a screening effect. Okay, but here the electrons are equally distributed in all orbitals, so attractive force is very strong between the outermost electron and the nucleus. Okay, so increase the stability. Here stability also increases. Okay, these are about the symmetrical distribution of electrons. Understood? Okay, I hope all of you understood about that. Second one, we are going to study about exchange energy. Exchange energy. What do you mean by exchange energy? If we are considering a half-filled orbital or completely filled orbitals, I am taking the half-filled orbital. Okay, half-filled d orbital I am taking now. These half-filled orbitals, the electrons in that orbitals which exchange their position, which can exchange their position within the orbital. Okay, this is the half-filled d orbital. This d orbital, within the orbitals, the electrons which can exchange their position. Okay, when they are exchanging their position, the released energy. Okay, when they are exchanging their position, exchange means this electron, it can exchange their position with here. Okay, or here, or here, or here. Okay, this is the exchanging position. When it exchanging, the energy will be released. Okay, this energy, it is called exchange energy. Okay, if more number of exchanges are possible, more energy is released. Okay, more number of exchanges are possible, more energy is released. Okay, which orbitals has the higher exchange energy, that is more stable than lower exchange energy. Okay, which orbital has the higher exchange energy? Higher exchange energy means which orbital has the higher number of possible orientation. Okay, higher number of possible orientation, that orbitals has released more energy, so that orbitals are more stable than lower exchange energy orbitals. Okay, for example, now I am taking the chromium. You know the electronic configuration for chromium, already Previous class we studied about that chromium atomic number 24. Here, what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 4d, 3d4. This is the expected configuration. Here the outer electronic configuration. How to write the electronic configuration? Short form of electronic configuration. For this 18 electron, we can take the noble gas in argon. Argon atomic number 18, we can take the stable electronic configuration. Argon we can take now. Okay, about you know clearly about that. And then 4s2, 3d4. Okay. When comparing, this is the expected configuration, but actual configuration for chromium, this is not stable. Okay, this expected configuration of chromium argon 4s2 3d4, it is not stable. Okay, but chromium, this is another configuration, argon 4s1 3d5. Previous class we studied about that clearly. The one electron from the s orbital, it goes to the d orbital. Okay, now the chromium atom will be stable. Why it is stable? Now we are going to study. So the d orbital here, how many electrons are there? 5 electrons. So it is stable half-filled configuration. Okay, was stable half-filled configuration. Okay, consider this electron. This electron, it can exchange this position to here. Okay, this electron can exchange their position to here, or here, or here, or here. Okay, this electron can exchange their position with this orbital, or this orbital, or this orbital, or this orbital. Okay, suppose it exchange their position with here, this electron will go here. Okay, suppose this electron exchange their position with this orbital, this electron will come to here. Okay, suppose this electron will exchange their position with this orbital, fourth orbital, the fourth orbital electron will come to the first electron place. Okay, suppose it exchange the position with this fifth orbital, this fifth orbital electron will come to the first orbital place. Okay, understood? This is the exchange. When exchange this electron, when exchanging the position, so much energy will be released by this electron. Okay, so here how much possible exchanges here? Totally 1, 2, 3, 4. 4 exchanges by the electron. Okay, suppose I am taking this electron. This is the half-filled d orbital. This 4 exchange possible here. Suppose I am taking this electron. Consider this electron. This electron can exchange their position with here. Okay, or here, or here. Okay, suppose this electron exchange the position with here. This electron come here. Okay, this electron go exchange here. This electron come here. Okay, so how for this orbital how much exchange is possible? 3 exchanges possible. 3 exchanges. Okay, understood? Suppose I am taking this half-filled orbital, d orbital. Consider this electron. This electron can exchange the position with here or here. Okay, 2 exchanges here possible. How much exchange is possible? 2 exchanges possible. Okay, and suppose I'm consider this electron means this electron can exchange the position with here. This electron can come here. Okay, here 1 exchange by electron. Okay, so overall electron exchanges for this half-filled configuration, here 4 exchanges plus 3 exchanges plus 2 exchanges plus 1 exchanges. Totally 4 plus 3 7. 7 plus 2, 9 plus 10 exchanges possible for the half-filled orbital of the chromium atom. Okay, 10 number of exchanges possible. Okay, so it can release more amount of energy. Okay, suppose I am taking the partially filled configuration, 3d4 configuration I am taking now, 3d4. This is the d orbital. How much electrons are having? Totally 4 electrons in the d orbital. Okay, this is not equally distributed also, so this not stable. And how much exchange energy, position possible here? This electron, consider this electron, it can exchange the position with here, here or here. Okay, so here how much exchange is possible? 3 exchanges possible. 3 exchanges. Okay, suppose I'm consider this electron, here how much exchange is possible? Only this electron can exchange here and here. Only 2 exchanges possible. Okay, and suppose I'm taking this electron, means only 1 exchange is possible. Okay, so here 3 exchanges possible, here 2 exchanges possible, here 1 exchange is possible. Okay, so total exchanges, how many exchanges are having? 3 plus 2 plus 1 is equal to totally 6 exchanges only possible here for the half-filled configuration. Sorry, partially filled configuration, only 6 exchanges only possible. Okay, so it can release low energy than the half-filled orbital configuration. Half-filled orbital configuration, more number of exchanges possible. Okay, okay, understood? The 3D orbital is half-filled and there are 10 possible exchanges. On the other hand, only 6 exchanges are possible for argon 3d4 and 4s2 configuration. Okay, 3d5 4s1 3d5 configuration, more exchanges possible. 10 possible exchanges are having, so it is very stable configuration than the argon 4s1 4s2 3d4 configuration. Understood? This increase the stability of half-filled 3D orbital. Okay, that is why the half-filled 3D orbitals are the stable. Okay, so these are about the exchange energy. Understood? Today your assignment: how the stability of half-filled orbitals increased due to exchange energy. How the stability of half-filled orbitals increased due to exchange energy. Okay, this is your assignment, today's assignment. If you have book, take your book now. I will mark the question. Students, take page number 56. Today's your homework. How the stability of half-filled orbitals increases due to exchange energy. From exchange energy, have to mark now. If 2 or more electrons with the same spin are present in degenerate orbitals, there is a possibility for exchanging their positions. Okay, listen here, this is the half-filled orbitals. Half-filled same spin degenerate orbital, 3D orbitals. During the exchange process, the energy is released, and the released energy is called exchange energy. Okay, here listen here, this is the 4 d orbitals. This is the half half-filled orbital, you know. Here, how much exchanges are possible here? This electron can exchange here, 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 here. Okay, 4 exchange. Okay, for this electron, it can exchange 4 positions. Okay, due to the exchanges, the energy will be released. Okay. If more number of exchanges are possible, more exchange energy is released. More number of exchanges possible, more exchange energy is released. Okay, more number of exchanges are possible only in case of half-filled and fully filled configurations. Okay, listen here. This is the half-filled configuration. This is the partially filled configuration. Okay. When compared to partially filled configuration, half-filled configuration have the more exchanges. Okay, 10 exchanges. Okay, overall electron exchanges, 10 exchanges. But partially filled configuration, only 6 exchanges are having here. Okay, for example, in chromium, the electronic configuration is orgon 3d5 4s1. The 3d orbital is half-filled and there are 10 possible exchanges as shown in your figure. On the other hand, only 6 exchanges are possible for orgon 3d4 4s2 configuration. Hence, exchange energy for the half-filled configuration is more. Okay, this increases the stability of half-filled 3d orbitals. Understood? You should draw the figure also. Very, very important. Okay. Up to here, you should mark. Okay. Students, second chapter we completed. Tomorrow onwards, we will study this third unit. Okay, we will go to the third unit. Second unit, just I recall what we have learned. Beginning of the chapter, we studied about the introduction to atom model. Whatever atom models we studied, Rutherford atom model, Bohr atom model, and the assumptions of Bohr atom model. Okay, the important Bohr assumptions of Bohr atom model. Maybe 3 more question maybe important. And then wave particles, duality of matter, de Broglie equation, important study de Broglie equation. And then Heisenberg uncertainty principle, important for 3 more question, very, very important, study that. And Schrodinger wave equation, this is also very, very important. Okay, book back question also, Schrodinger wave equation, book back question also. Okay, study very, very, very important, Schrodinger wave equation. And after that, 4th set of quantum numbers. You will study 4th set of quantum numbers, very, very important to write the electronic configuration. Okay, very, very important, study that. After that, we studied about the shapes of atomic orbitals, shape of s orbital, shape of p orbital, shape of d orbital and f orbital. And then energies of orbitals, we studied n plus L rule, important for 2 more question. Okay, n plus L rule important. And then we studied filling of atomic orbitals, alpha principle, Pauli exclusion principle and Hans rule. This is very, very important. Alpha principle and Pauli's exclusion principle. This is book back question also for 3 more question. Very, very important. Okay, alpha principle, Pauli exclusion principle, Hans rule. These 3 principles you should study well. Okay, very, very important. After that, electronic configuration of atom, we studied how to write the electronic configuration. I hope all of you understood about that. Very, very important for our further studies. This is important. If you have any doubt, you ask me. And then today we studied stability of half-filled and completely filled orbital. Okay, stability, the half-filled and completely filled orbital, it is very stable than partially filled orbital. Okay, how it is very stable, we studied because of the exchange energy. Okay, the half-filled orbital, because of exchange by the electrons, during the exchange of electrons, their energy is released. Okay, excess energy is released. So large number of exchanges, electron exchanges, there are very high energy released, so it is very stable, very high stable. When compared to half-filled, when compared to completely filled and half-filled, completely filled orbitals are very stable than half-filled orbital. Okay, when compared to half-filled and completely filled and partially filled orbitals, half-filled orbital and completely filled orbitals are very stable. Okay, important question. Study well. Today's assignment, study well. Okay, thank you.